Now see, in this numerical, they have given you velocity time graph, and from this graph, first of all, you need to calculate the acceleration in the region AB. Now we need to calculate the acceleration in the region AB, so that means we need to calculate slope of this region. So the first part says we need to calculate the acceleration in region AB, so you will be calculating slope of AB. So you will be using the formula y2 minus y1 upon x2 minus x1. Now for these 2 points A and B, as you can see, A is on the origin, so you can say that for point A, x1 is 0 as well as y1 is also 0. Considering the second point B, here you can see at B value of x is 12 and for y it is 14. So for B, x2 is 12 and y2 is 14. Now substituting these values here, y2 minus y1, so you will be getting 14 minus 0 upon x2 minus x1, so 12 minus 0. So that will give you 14 upon 12, that makes it 7 upon 6, and the unit, according to the unit of velocity and time, it will be meter per second square. So this we have got acceleration in the region AB. Now the second part says you have to calculate the deceleration in the region BC. Now to calculate the deceleration, again the same formula, we need to calculate deceleration in the region BC. We will calculate acceleration and it will come out to be negative, showing that there is retardation. Okay. So we will again using the acceleration formula. So for that we need to calculate slope of BC. Slope of BC. Same formula, y2 minus y1 upon x2 minus x1. Now you can see we have the 2 points B and C. B is the first point. So here value of x is 12 and y is 14. So for B you are getting x1 is 12 and y1 is 14. Whereas for C is the second point. Here you can see value for x is 16 and for y it is 6. So x2 is 16 and y2 is 6. Substituting these values over here. So let's substitute these values. Y2 minus y1, so 6 minus 14 upon x2 minus x1, so 16 minus 12. So that will give you minus 8 upon 4. So you will be getting minus 2 meter per second square. So as you can see that acceleration is negative, so we can call it as retardation. Okay, now let's see what we have to get in the third part. So in the third part they are saying you have to calculate the distance covered in the region ABCE. In the region ABCE, they have asked you to calculate the distance covered. Now how to calculate the distance covered in the region ABE? Okay, so third part, we need to calculate distance in the region ABCE. Now for that you will need to calculate the area of this figure. So we'll be calculating area of the figure ABCE. Now what we will do here in the graph, we will divide this region A, B, C, E in two parts. Now how will you divide it in two parts? Now let us consider, see this region, as you can see this portion which I have marked here, highlighted here, this is a trapezium. So first you will get area of this trapezium, and then this second region over here, you can see this second region is representing a triangle. So you will get area of the triangle plus the area of trapezium, and that will give us the total area, that is the distance. So what we are going to do over here, I will mark this point as F. So the region ABCE has been divided into two parts. Now what are those two parts? One is the triangle, so we will get area of triangle ABF, and the second one is a trapezium, so you will get the area of trapezium BCEF. Now for the area of triangle, it's a right angle triangle. You can see base is from 0 to 12, that is 12. Base is 12 into height. Now from B to F, this is the height. So as you can see in the graph, this height BF, it is from 0 to 14. So you can say height is 14. So this will give you area of triangle. Now we will get area of trapezium. Now formula for the area of trapezium is half. Now we need sum of parallel sides. Now in the figure you can see these two sides are the parallel sides. So we need to get the length of these two parallel sides. So the length of BF, as you can see from the graph, is 14, plus the other parallel side is CE. So you can see from the graph this length CE is equivalent to 8. And then we have height. Height means perpendicular distance between the two parallel sides. So FE is the perpendicular distance, which is from 12 to 16, that is 4. So from here, now if we add these two area, we will get the area, total area, that will represent the distance. So here this on reducing to 6, this will give you 84. This will give you half. 14 plus 8 will give you 22 into 4. So you divide it. So this will give you 84 plus 44, that makes it 128 meter. So this will be the distance traveled in the region A, B, C, E. Okay, now the fourth part. Now the fourth part says you have to calculate average velocity. We need to calculate average velocity in the region CED. Now this is the region CED, and we need to calculate average velocity in this region. Now to calculate the average velocity in the region CED, first we will get distance traveled in the region CED. So as you can see from the figure, distance traveled in the region CED will be equal to the area of the triangle CED. So first of all, we are going to get distance covered in region CED. Now the region CED is a triangle, so you can get the area of triangle. Now for the region CED, you see here base is from 16 to 28. Base is from 16 to 28. If you subtract it, you will get base as 12. So base we are getting as 12. Okay, then CE, this is the height. So as you can see, height is 6, so into 6. So this will give you distance covered in the region CED. So the distance covered in the region is 36 meter. Okay, now we also need the time in the region CED. So as you can see from the graph, time in the region CED is from 16 to 28. In the region CED, you can see time is from 16 to 28. So that means time taken, you will subtract it. So 28 minus 16. So time in region CED, it is from 16 to 28. So that will give you 12 seconds. Now we have got the distance covered, we have got the time taken, so we can get the average velocity here. So let's find the average velocity. Total distance upon total time. So here the distance covered is 36 and the time taken is 12. So that will give you 3 meter per second. This is clear to you now?